Hello everyone, and welcome to the Production Energy Analytics case study. Thank you for the intro, Liz. My name is Kelsey Wiggin, and I'm a consultant with Thorogood. I'm over from our Philadelphia office. Happy to escape the ice and snow for a couple of days. So over the past couple of months, I've been working with one of our customers to forecast energy consumption at their production facilities. And we're going to take a look at how we've done that for them. We're going to start with some background to the customer. We'll talk about their goals, as well as the previous approach that they were taking to forecast energy. And then we're going to take a look at the solution that we built for them, and I'm going to demonstrate that solution for you. So first to start with, let's talk about some background to the customer that we're working with. They're a large consumer packaged goods firm, and they have products within many categories. They have global, well-recognized brands around the world. They own and manage their own production facilities, and these are, again, global facilities all over the world. One thing to keep in mind, which Trevor touched upon, is they have local and global needs because they're all over the world. So their goal, they had three main targets that we were looking at. The first one, which I mentioned, was to reduce energy consumption at their production facilities. And this led to a couple of other goals. The first one being cost reduction. That's pretty simple. We know that energy costs money. If you can reduce the energy consumption at your facilities, then you can save some money. The second one being corporate responsibility. So currently in the world, there's a lot of people that are moving towards going green and increasing sustainability so that we can save our planet for future generations. From a corporation's perspective, it's important to ensure that you don't make any big mistakes here, because we've seen from companies like BP that one mistake can be a fatal error for maintaining customers and for adding new customers to your business. Our client in particular is very focused on corporate responsibility. They want to ensure that they're maintaining and improving their image, that they're not making any of those big mistakes. And also for their stakeholders and the people working at their facilities, it can feel good to know that your footprint on the earth is something to be proud of. So now let's talk about the approach towards moving towards reducing energy consumption. So what they look to do on the right-hand side here is to set an energy target for a given production facility and an upcoming year. So what is an energy target? An energy target is an attainable goal, a stretch goal for that production facility to work towards in the coming year. And how do we create an energy target? We take into consideration two different things. First, we take into consideration an energy forecast for that production facility and the upcoming year. So let's think about what an energy forecast is. We know that there's some relationship between production volumes and energy consumption at these facilities. So if you're producing more volume, more units of your products, you're going to have more machines on, you're going to have more machines on for longer amounts of time. Now, if we know what that relationship between production volume and energy consumption looks like looking backwards, an energy forecast would assume the same relationship moving forwards. But with our client, they didn't want to just assume the same relationship moving forward. They want to improve their energy consumption and that relationship. And that's where an energy initiative comes into play. And for each of these production facilities, they have different energy initiatives. And energy initiatives are strategic plans in moving towards reduction of energy consumption. So I could give a few examples, things like training sessions for factory workers, to like best practices for using machinery to reduce energy consumption. Or another example would be changing the types of light bulbs in your facility to save energy. So that's all going to be very specific for each of the production facilities. And once we understand that energy initiative for an upcoming year, we can take the energy forecast, which assumes that same relationship we've seen looking backwards, reduce it by some percentage based on the energy initiative, and result in an energy target. So that's, at a high level, the process that's used. Now, this wasn't new to the customer. in particular, we were looking at one supply chain manager who was responsible for forecasting energy. And that forecast bit of the energy target setting is where we're going to focus our time. So he was already forecasting energy to reach these targets, looking backwards. And how is he doing that? So I know that I talked about how there's a relationship between production volume and energy consumption. How do we explain that relationship? He explained it using a linear statistical model. And in particular, he was looking at it at a detail of manufacturing facility, product, and year. So what he ended up with was, for a given production facility, one value for the upcoming year for the energy consumption forecast. And how did he do this? He used Excel. So he actually was creating a separate linear model for each of the production facilities. Not only was he doing that, but he was bringing in all that historical data. He was bringing in planned production volume data. He was storing that in his Excel spreadsheet. He was doing a degree of formatting and lookups, and then creating a separate sheet for each of the factories. And then from there, for each of the factories, he was running statistical models separately for each one. So we knew that there was a lot of manual effort involved, and he was doing this once or twice a year. So every time that he wanted to do it, he essentially recreated this spreadsheet from scratch. We've probably all been involved in manual Excel spreadsheets at some time, and we know how difficult they can be. There were also some reliability concerns with this approach. So the data that he was bringing into the Excel spreadsheet, he would get through shared drives or through emails. We know that data can be lost along the way, things can be changed. Wasn't allowing for one version of the truth. And there were also some modeling limitations. So we know that Excel is not built primarily to be a statistical tool. Although it does have statistical modeling capabilities, they are limited to some degree. So this supply chain manager in particular, we'd worked with him previously. We'd built a sustainability dashboard for him. And the sustainability dashboard included metrics like energy consumption, as well as greenhouse gas emissions, that sort of thing. If you're interested in talking more about that, feel free to come talk to me during one of our breaks or at lunchtime. So we worked with him on that solution. He was familiar in working with us and knew that we could build user-friendly and easy solutions. So he came to us and he asked, okay, I have this Excel model. I have this Excel spreadsheet. I'm creating statistical models. It takes me a very long time. Is there anything that you can do to help me? And in looking at the way that he was creating those models, we knew that we could help with reducing those manual efforts, but we also thought that we could help in a couple of other ways as well. So our proposed solution ended up being a three-pronged approach. The first was to integrate. So in his previous approach, he was keeping his statistics and analytics separate from the rest of his dashboarding and reporting. What we wanted to do was integrate his analytics into the current BI landscape. This would simplify the process. It would allow it to be integrated into his day-to-day routine. It would also allow for one version of the truth with the data. We also, as I already mentioned, wanted to automate the process for him. So something that was taking him hours or even days to do, we wanted to make it seconds or maybe minutes. And that would free up a lot of his time to focus on something like improving the energy initiatives at the production facilities to eventually get to more specific and robust targets. And finally, we wanted to expand the functionality. So I mentioned that Excel has some limitations, and what we were looking to do was use robust statistical tools to have almost limitless possibilities with analytics. So we proposed to integrate two different technologies together. The first one was QlikView. And QlikView was used as the data model and front-end portion of the solution. QlikView is an in-memory reporting tool. It's the in-house standard BI tool at the customer that we are working with. I mentioned that we built that sustainability dashboard for them. That was in QlikView. There were a number of other supply chain applications already in QlikView that this user was also looking at. And there are a number of other applications across the company that were also in QlikView as well. So he was very familiar with it. And actually, all of the data that we needed for the application was already on the QlikView server and in QlikView files. We knew that it would allow us for one version of the truth with the data, which is one thing we were striving towards. The other technology that we were looking at is R. R, which has been mentioned a couple of times in the presentation so far, is a statistical modeling tool. It has open source code, and it's used widely in academia, also across industry as well. So R was a new software at our customer. It was something that we proposed to them. They were excited to give it a try. They knew that since it was open source, it was something that they could quickly get started with, and we moved forward with that approach. So I'm going to jump into the demo in a few minutes, but first I want to give a brief background of what our data model looks like. So I mentioned that the way that we create our statistical models is with our historical volume and our historical energy, and we describe that relationship with the model. So that's a part of the fact data that we need to bring in. We also need to bring in plan volume data. And once we have plan volume data, we can use our model to calculate what the forecast energy is going to be. From a dimensional perspective, we included data at the granularity of production facility, which was similar to what we were seeing in the Excel spreadsheet. Also at the level of product, again, similar to what we were seeing in the Excel spreadsheet. And then from a time perspective, we brought it in at the granularity of month. So that was a bit different than we were seeing in the Excel spreadsheet. Previously, he was doing it at the year level and creating one forecast value for the entire year for a production facility. So first thing to note is that I mentioned that data was already on the QlikView server. It was also already at the granularity of month. So it essentially took us no more time to bring it in at the month level versus at the year level. It increased our data volumes, but that ended up being a good thing for us. So by having it at the month level, it did a couple of things. Because we had many more data points now to create our statistical models, it resulted in a more robust and reliable model. Also looking forward, now we would have our energy forecasts at the month level instead of at the year level. This would allow for potentially setting energy targets at the month level as well. And if you can give a production facility manager their energy targets at the month level, it's something that they can integrate more fluidly into their monthly processes versus having the entire year and looking at it at the end of the year, at the beginning of the year, kind of harder to wrap your head around on a day-to-day. So we thought that that was really beneficial in a couple of different ways. That was one way that we were able to expand that functionality, as I mentioned earlier. So now let's talk briefly about how the application works before we take a look at the demonstration. So we see that we have our source data on the left-hand side. That I mentioned is the historical energy, the historical production volumes, and the plan energy. And that gets loaded into a QlikView data model file where we do some ETL processes, cleansing, and formatting of the data. Finally, we bring that into the QlikView presentation layer. And in the presentation layer, we have some visualizations, front-end reporting that a user can interface with. The presentation layer also has the ability to call R. And we'll take a look at how exactly that's done. But when the presentation layer calls R, it outputs a data file that R then picks up, and R runs a script, and it outputs the energy forecast. QlikView then picks up the new file and loads it into the presentation layer. So that should help us a bit when we're taking a look at the demonstration to understand what exactly is going on in the background. And now we're going to open that up. What we're going to take a look at are some key visualizations that our user was using, also some key metrics. We are going to look at how we can run a forecast in call R, and then also some interactive capability that we were able to give the users of the application. Okay, so when we open the application, let's say we're that supply chain manager who's going to be running some forecasts. What we see in the top here is in the top section there is a trend chart, and that's a really important part of the reporting for our supply chain manager. It allows him to see the relationship between volume and energy. We see that we have months along the x-axis. We have a left-hand y-axis that is showing thousands of units, and that's for the volume. And then we have a right-hand y-axis, which is showing gigajoules, and that's representing energy. We have a blue line, which is the volume, and then we have the green line, which is energy. We can see that the blue line, it runs from about 2011 P1 through to 2016 P10. So for volume, we already have historical volume and our planned volume loaded into the application. For energy, we stop at about 2014 P12 here. And that's because at this point, we only have historical energy. We still need to run the regression to bring in those forecasted energy numbers. We also have a chart along the bottom here, which is displaying by factory the energy efficiency. And energy efficiency is one of those key metrics. We actually use this metric as well in the sustainability dashboard that I've mentioned. And it is an energy divided by volume calculation. You end up with gigajoules per thousands of units. And a smaller energy efficiency means that it's a more efficient factory. And we can use this metric once we've run our forecasts is when we'd want to come back to it. But we can use it to kind of identify some of these factories where we might want to maybe focus on those energy initiatives, see if we can make them more efficient. We also have a number of filters here in the top left. QlikView, it's very simple to make your filter selections and apply them to your charts. We have period, product, factory, and measure. And I can quickly show you, oops, I need to select all those, but that works too. I can quickly show you how we can make one selection and see how the charts filter down. You can easily clear them out as well. We have a number of model settings, and I mentioned there was some interactivity we've included in the application. We're going to come back to that in a few minutes. And then we also have a couple of buttons. So the run regression button, that's what's going to call R. As I mentioned, it's outputting a file. R is picking up the file, running the forecast, outputting it, and QlikView is loading it in. We also have a refresh data button. So that's actually going to refresh our historical volume and energy, as well as our planned volume, and load it back into the application, essentially resetting everything, allowing us to run some fresh forecasts. We can set that up on a schedule to run daily or monthly, but the user of the application might also want the ability to do it from the front end, and we'll take a look at why in a couple of minutes. So first, why don't we go ahead and run our regression. The supply chain manager's entered the application. That's the first thing he's going to do before he starts digging into any of the details. So we're just going to click the button. There's a bit of stuff happening in the background, and very quickly we see that we have a new green line here, which is showing our forecasted energy, which R has outputted. And you'll notice that that was very quick. I did want to note that we have about 90% of the original data volumes that we were using in this enterprise application. Certainly not the larger data set that we've seen at corporations, but it does show that R is built for large data sets. So now let's say we want to dig into one of these factories. As I mentioned, each of the models is distinct by factory. So it's really more relevant when we do that. We can take a look at the historical relationship between volume and energy, as well as our plan and forecasts moving forward. So we see that there's a spike here in 2016 P1, and because there's a spike in volume, there's going to be that related spike in energy. And let's say that we've heard from the demand planning team that they actually don't think they're going to be able to meet those goals that they've set. They're potentially looking to reduce that plan in production volume. We're interested in taking a look at, okay, if they're going to reduce that production volume, what would be the impact on energy? And we can actually do that from the application. So we're going to flip over to our data overview tab here. And first, to talk through what we're seeing here. Along the top, we see that there is a data table, and that is essentially all of the data that is used to create the forecasts, as well as the forecasts themselves, at the level of granularity that we do that. Along the bottom, we also have some model analysis statistics. Gives the user a better idea of how well fit the model is. Gives R-squared values, coefficients, standard errors, that sort of thing. This was outputted by R, and it does so every time that it runs a forecast, and loaded into the application every time it loads a new forecast in as well. And there's a number of additional information that R can output, but this was specifically what our manager was interested in seeing. OK, so we knew that we saw that spike in 2016 P1, and we wanted to see if we could make some adjustments to it. OK, so once we filter down, our data table filters down as well. We see that we have a few different values for planned volume and a forecast energy based on the different products. And we've been told that this bath bomb product type is where we would potentially be reducing the production volume for the plan. And so what we have the ability to do here is write back adjustments to the planned volume to see what the resulting energy forecast would look like. And we can just click into this box here, and we are going to reduce it by around 4,500 units. And so from a functionality perspective, we wanted to give the ability for the user to have controlled what-if functionality. And we know that in Excel, he could essentially change any numbers that he wanted to. He had complete freedom to do that. But when doing that in Excel, it can result in errors. It can result in losing track of the changes that you've made. There's just a number of issues that can come from it. And what we've done in QlikView is we've controlled and removed the degree of error, allowed the ability to quickly and easily refresh the data to get back to where you want, while still using what-if analysis to see, well, if I change this, what's it going to look like? Now that we've made that adjustment, we can very quickly and easily run a new regression. Come back over to this tab. I'm going to click into Berlin, and in 2016 P1, where we were seeing that spike in volume and related spike in energy, we no longer are seeing that spike after the reduction in volume that we've made. One other bit of functionality that we were able to give was the ability to adjust the months, the start month and the end month, for creating the model itself. So by default, we have it set to 4 years, at 4 years back, and then through to the last close period. But let's say that we have some understanding and we've dug into the details, and we see that the year 2011 actually isn't very relevant to that relationship between production volume and energy. We find out there was something else going on. We can actually come in here and adjust that start date. We can just quickly type that in. Change it to 2012 P1. So now the model is only going to run from 2012 P1 through to 2014 P12. And we might want to adjust that end date if we have something like a delay in data coming through during month close. That's something that we've seen before. So now that we've adjusted that, we can rerun the regression again. Click into Berlin again. And we see that now we only have 2012 P1. And what was outputted to R was only 2012 P1 through. And now our model and related coefficients are going to be adjusted to reflect that new time period. Finally, if we've come through and we've made a number of changes and we decide that we want to go back to the original state and refresh everything, we can quickly refresh the data. It loads in that file from our ETL layer. So I will just show how we can do that quickly. It always flips to another page. There we go. OK. And so now we can see we no longer have our energy forecast values through. And we see that spike in Berlin again at 2016 P1. So we've refreshed all that original data. OK, and now I'm going to take us back to the presentation. So just to review what we looked at in the demonstration, we took a look at some visualizations and key metrics that a user might be interested from an energy perspective. We took a look at how we could call R from the front-end application. We took a look at that controlled what-if analysis that we were able to give the user. And finally, we saw how we could refresh the data and return it back to its original state. So this implementation was a first release with the customer, and we know that there's a number of different directions that we can go from here, and we're really excited about what's possible. So the big question is, what's next? One thing that we'd look to do is improve the statistical model. So we started with the linear model. We know that is a good description, but we would be interested in looking at additional types of models and potentially even changing that from the front-end application. Something like a seasonal model might be appropriate. We could also look to bring in additional variables which might help explain the relationship between production volumes and energy consumption. So again, perhaps weather trends might play into that. We could also look to bring in some additional granularity of data. So if we were able to get our energy consumption at a machinery level within the factories instead of at the factory level, then that might make our model a bit more precise. We could also look to improve the front-end reporting. So although we saw a couple of visualizations, we know that there's further we can go in that direction, potentially with integrating additional data into the application as well. And finally, further integration. So I mentioned that there are a number of supply chain applications that are already built into QlikView for this particular customer. Now that this forecast data is on the QlikView server, it's pretty straightforward to load it into another application and present it there. Also, I mentioned it's not just an energy forecast, but also energy initiatives that lead us to that energy target. So we could look to bring in the energy initiative data and see if we can even set energy targets from the front end of QlikView. I think we can do it. And that wraps up my presentation. I am going to bring Liz back on stage now, and we are going to open it up for any questions before I hand it back off to her.